Human beings are just naturally curious creatures. From the moment we're born, we're constantly exploring our surroundings, testing boundaries, and asking a million questions about how things work. In this explainer, we aren't going to look at science as some boring, static body of facts you have to memorize for a test. No way. Instead, we're looking at it as an ongoing, incredibly dynamic process. And it's a process driven entirely by one fundamental force: curiosity. We're going to explore how that innate, burning desire to understand our environment scales from basic everyday observations all the way up to complex scientific disciplines. Because really, asking why is the absolute foundation of every major discovery we have ever made.
Okay, let's dive into this. Have you ever just stood outside on a dark, clear night, looked up at that massive, sprawling sky, and genuinely wondered, why exactly do those stars shine? Or maybe you've watched a flower blooming and thought about the invisible biological triggers that signal it to open at exactly the right time. These are grand, beautifully fundamental questions. But more importantly, they are the exact foundational drivers of entire fields, like astrophysics and botany. Asking these kinds of questions is the vital first step. It takes a fleeting moment of wonder and turns it into a rigorous pursuit of actual knowledge.
Think of science like a giant, unending jigsaw puzzle. Every single discovery we make, whether we're mapping out the gravitational pull of some distant galaxy or modeling how a tiny subatomic particle behaves, it essentially locks a brand new piece into place, expanding our understanding of the universe. And the absolute coolest part about this pursuit, there is literally no limit. Every new piece of knowledge we find naturally sparks even more questions. Sometimes we even realize an old piece was jammed into the wrong spot, and new data forces us to completely reevaluate and shift our understanding. It's wild. And hey, this puzzle isn't just floating up there in outer space either. If we pivot from the vast vacuum of space all the way down to the extreme crushing pressures of the ocean depths, the actual mechanics of discovery don't change one bit. Groundbreaking insights pop up all the time from the most inaccessible, unexpected places on Earth. There are entirely distinct ecosystems, weird chemical processes, and bizarre biological adaptations just waiting to be discovered right beneath the waves. It just goes to show that inquiry isn't limited by geography at all. It works everywhere. Whether we're analyzing the rocky geology of massive snow-capped mountains, studying the complex ecology of a thick green forest, or figuring out the thermal dynamics of rolling desert dunes, the underlying principle is exactly the same. Systematic inquiry scales across literally any environment. From studying the mineral makeup of a single tiny grain of sand to mapping out massive climate patterns across a whole continent, curiosity simply doesn't care about the size or location of what you're studying. It's just that relentless desire to decode reality. So, science absolutely isn't just a heavy textbook filled with data points that you're forced to accept at face value. Actually, it's a methodology. It's a highly structured way of thinking, observing, and experimenting to test what we think we know about the world. We formulate questions, we design clever ways to explore them, and we analyze what happens to understand how things operate. And the engine driving this entire intellectual vehicle, that's curiosity. Without that initial spark, that itch to look closer and ask why, the whole engine of discovery just grinds to a halt. Let's zoom way in for a second, from the massive secrets of the universe directly into the micro level of our daily routines. Your kitchen, for example, it's basically a highly active laboratory. When you're wondering what makes those diverse, tasty regional Indian dishes so good, you're actually experimenting with chemistry and thermodynamics. What causes that Maillard reaction that browns our food and gives it that amazing flavor? How do fats and acids mix to create stable emulsions? The chemical transformations happening right there in a hot frying pan are just as ripe for scientific inquiry as a fusion reaction happening inside a star. This curiosity naturally extends to the weather and thermal dynamics we experience every single day. Think about something as simple as jumping in a rain puddle, or wondering why water freezes into solid ice. We see water change into a crystalline structure when it gets cold, and vaporize into a gas when we heat it up on the stove. Understanding these basic ideas helps us grasp everything from local weather patterns and the global water cycle, all the way to how our own body regulates its temperature when we're fighting off a fever. It's literally everyday physics and chemistry in action. And it definitely doesn't stop there. The totally mundane objects sitting around us right now are packed with mysteries. Think about the paper we write on, a standard metal key, a plastic ruler, a rubber eraser, or even the woven clothes we're wearing. How do the unique molecular structures of these everyday materials dictate what they can actually do? Why does a magnet stick to some metals but completely ignore others? When you apply that curious mindset, our immediate, boring physical surroundings turn into an absolute goldmine for understanding material science. So here is the really empowering part. You are already a scientist. We all instinctively apply the scientific method in our daily lives, often without even realizing we're doing it. We are constantly observing our environment, spotting when things aren't quite right, and running little mini experiments to figure out solutions. The fancy formalized process that academic researchers use in a sterile lab, it's fundamentally just a more rigorous documented version of the exact same cognitive process you use to get through your typical Tuesday.
Okay, picture this. You're writing something down and suddenly your pen just stops working. Instinctively, your brain formulates a question. Why did the ink stop? Next, you make a guess, a hypothesis, that maybe the ink is just empty. Then you test that hypothesis by unscrewing the pen to look inside. If the tube is empty, boom, your hypothesis is validated. But if there's still ink in there, well, your first guess was wrong, so you make a new one. Maybe the ink's dried up or there's an air bubble. Without even trying, you just systematically applied observation, hypothesis, testing, and revision. That's the scientific method.
We see this kind of applied science everywhere, especially when people are troubleshooting. Take a bicycle mechanic trying to find a microscopic leak in a flat tire, or an electrician trying to figure out why a light bulb isn't turning on. They are fundamentally running diagnostic experiments. They're eliminating variables one by one to find the root cause of the problem. By systematically asking how and why to fix practical problems, they're using the exact same logical framework used to decode the grandest mysteries of the cosmos. Now, it's absolutely crucial to remember that this unending puzzle is rarely solved alone. Modern science relies so heavily on teamwork. Researchers all over the world work in huge, interconnected networks. They share their data, they challenge each other's methods, and they independently verify the results. When someone comes up with a new hypothesis, it has to survive the scrutiny of the whole community. This collaboration is what ensures that our collective understanding is actually accurate, objective, and constantly getting better over time. Which brings us to a final thought I want to leave you with today. If you had to ask why about something you saw today, what would it be? The goal here is to actively look at your surroundings through an analytical, curious lens. When you bump into something you don't fully understand, don't just ignore it. Lean right into that curiosity. Make a guess and figure out how you might test it. Grasping this method sharpens our ability to solve really complex problems, but the spark for that entire process will always be an active, questioning mind. Keep asking